Oh, hello there. Did you know basketball is my favorite sport? Did you know there's a lot of science involved in the game of basketball? In fact, there's a lot of science involved in just dribbling a basketball. For example, there are two types of energies involved in dribbling a basketball. The first is potential energy. Potential energy is the energy stored in the object due to its height above the ground. Come on over here, I'll show you what I mean. The ball on my hip has potential energy because I'm holding it above the floor. Here is a little potential energy. Here, more potential energy. Here, a lot of potential energy. The other type of energy is kinetic energy. Kinetic energy is the energy an object has due to its motion. Come on over here. I'll use my sister as an example of kinetic energy. For example, if I hold the ball right next to my sister, it's not moving. There's no kinetic energy. But if I take a step back and throw it at her, ow! The purpose of today's experiment is to see which surface is best for bouncing a basketball. We want a...
You just want to pick it up from the second sentence?
Yeah.
Go ahead.
We want a surface where a basketball bounces back as high as possible when it is dribbled. We are going to drop a basketball from 3 different heights into 3 different surfaces, measuring how high the basketball bounces. The first one, tile. The second one, carpet. Third one, lid. Let's see which surface and which height maximizes the ball's potential energy and renames the ball's kinetic energy. First, we're going to drop the ball from the 3-foot mark and drop it on the surface.
Point to the 3-foot mark, Quentin. Okay, ready? Go ahead, anytime. Okay, do it again. Anytime. Okay, there. Okay.
So now, we're going to drop the ball from the 3-foot mark onto the carpet.
Okay, do it again. Do it one more time.
That was about 2 feet. So now we're going to drop the ball from the 3-foot and drop it on the plastic.
Okay, do it again. Hold it ever so slightly at the 3-foot mark. One more time.
Now let's raise the ball higher and increase both its potential and kinetic energy. Helping me is my 13-year-old cousin Rachel.
8 feet. Okay, there's one. Do it 2 more times. Thank you, Rachel.
You're welcome.
Now we're going to use the plastic and the carpet, but first the carpet.
One more. Okay. Now, onto the plastic. Thank you, Rachel.
You're welcome.
Now, let's raise the ball even higher and increase both its potential and its kinetic energy. Helping me is Isaac, 11 years
Go
old.
on. Go, Isaac.
Oh, that's a sucker.
Do it again, buddy. Okay, Isaac, do it one more time. Oh, that was good. Isaac, will you do it another time too?
Ow. My head. I'm sorry.
Okay.
Now, we're going to put this carpet down here so you can drop the ball.
Isaac, how you doing? Ready when you are. There's one. There's two.
Whoa.
And there's three. Good job. Okay, Quentin, tell us what we're going to use down here now.
Now, we're going to use the lid.
All right, what's the lid made out of?
Lid.
Plastic.
Plastic.
Plastic. Hold on, Isaac. Okay, the lid is in place. Isaac, we're ready when you are. Did it hit the plastic?
Yes.
Do it again. Do it again.
Last one.
All right. Good job, Isaac. Give me a high sign.
Good job, Pop.
No, don't you put your arm around me.
Okay, Quentin. We're going to study the videotape in a moment
Oh, gosh.
and examine the results. But what were your initial observations?
That's
Off of which surface did the ball bounce the highest?
the tile.
Off the tile, okay? And from what height did the ball bounce the
The
highest?
highest.
The highest, because what kind of energy was at the greatest up high?
The highest potential energy.
The highest potential energy. That's right. And which height produced the greatest kinetic energy?
I think the highest.
The highest, because the ball bounced up the highest, didn't it? Okay, good job, guys. Thank you for your help. Say, on the count of three, say, science is fun. 1, 2, 3.
One.
Say, K-State rules. 1, 2, 3. Okay, Quentin, here are the graph results of our experiment. Each graph represents the distance that the ball bounced. Over here on the left, from 3 feet, off of tile, carpet, and plastic. And again at 8 feet, tile, carpet, plastic from 13 feet. Quentin, what do you notice about these results? What hits you right away?
When the ball hit the plastic, when dropped at a lower height, it wouldn't bounce very high.
Right,
But
right.
when the ball was dropped at a high distance on the plastic, it was as high as the tile.
Right. The ball bounced just about as high off the plastic as it did from the tile. Yeah. Okay, good. And why do you think that was?
Because the plastic was able to absorb the energy from a lower drop, but not from a higher drop.
The plastic was able to absorb the energy from a lower drop, and therefore the ball didn't bounce back as high.
Yeah.
Okay. And what else do you notice here? What else do you notice the relationship between potential and kinetic energy?
A lot of potential energy now leads to more potential energy later.
Say that again.
Lots of potential
Lots of
energy
potential energy.
now leads to more potential energy later.
Right. The ball had lots of potential energy when held at 13 feet. And then when it was dropped, it turned into kinetic energy. and bounced a lot higher than when the ball was dropped from 3 feet or 8 feet. Right?
Yeah.
Okay. And which was the most responsive surface overall?
I think it's the title.
The tile?
Yeah.
So do you think it's good that basketball is played on a hard surface or a soft surface?
A soft surface.
Really? Why?
Because soft surfaces will less hurt when you fall over.
But what about in terms of bouncing the basketball?
Well, a hard surface then, because then it bounces back easier.
It bounces back easier. Okay. Good job, Q.
Now let's raise the ball higher and increase both its pollution. Wait. How do you say that?
Potential.
Potential.
Third